This is a video from the Chapter 6 review in Calculus 2. The directions say to find the volume of the solid obtained by rotating the region bounded by the given curves about the specified axis. So in problem 6, the curves are y equals x squared plus 1, y equals 9 minus x squared, and we're going to rotate the region bounded by those curves about the line y equals negative 1. So y equals x squared plus 1 is a parabola, and it's in black. Y equals 9 minus x squared is another parabola in blue. And the region is this shaded piece right here. And we're rotating that region about the line y equals negative 1. And so what I want to do is I want to draw a typical rectangle in that shaded region. So if we draw a typical rectangle here, we're going to use the disc washer method to calculate the volume. Now, in order to do that, we need to find the outer radius and we need to find the inner radius. So to get the outer radius, the distance from that top function to the x-axis is 9 minus x squared. The distance from the x-axis to the line y equals negative 1 is 1. So the outer radius will be 9 minus x squared plus 1, which is 10 minus x squared. For the inner radius, the distance from the bottom function to the x-axis is x squared plus 1. The distance from the x-axis to the line y equals negative 1 is 1. And so the inner radius will be x squared plus 1, which is equal to 2 plus x squared. And I'm ready to set up my integral, almost. Now, utilizing the disc washer method, we're going to find the limits, and to do that, and what I'm talking about, by the way, is the limits of integration. So I'm going to set 9 minus x squared equal to x squared plus 1. Solving for x, we get x equals plus or minus 2. So the volume is equal to pi times the integral from negative 2 to 2 of the outer radius squared, which is 10 minus x squared raised to the second, minus the inner radius squared, which is 2 plus x squared raised to the second. And we're going to integrate this with respect to x. So this is pi times the integral from negative 2 to 2 of 100 minus 20x squared plus x to the fourth minus the quantity 4 plus 4x squared plus x to the fourth. So notice how these x to the fourth terms cancel, like so. And when we simplify this integrand, we get the following. We get pi times the integral from negative 2 to 2 of 96 minus 24x squared dx, which is pi times the quantity 96x minus 8x cubed evaluated from negative 2 to 2. So this is pi times the quantity, and I'm going to replace x with 2, and I get 192 minus 64. And then I'm going to go minus, and then I'm going to replace x with negative 2. And when I do that, I get minus the quantity negative 192 plus 64. And when you guys plug that in, you should come up with 256 pi. And with that, we're going to take a look at problem 8. Suppose y equals sine x and y equals cosine x, where x is between 0 and pi over 4. And we're going to rotate that region about the line y equals -1. So if we draw a picture, here's y, and here's x, right? So we have the y-axis, we have the x-axis. Now, to graph y equals sine of x, when x is 0, y is 0. When x is pi over 4, my corresponding y value will be 1 over the square root of 2. So let's just suppose it's there. And that's y equals sine x. Now, if we want to graph y equals cosine x, so we're going to extend that y-axis up a little bit here. And we're going to put 1 up here. So when x is 0, cosine of 0 is 1. And then when x is pi over 4, cosine of pi over 4 is also 1 over the square root of 2. So we're looking like this. Now, we're going to rotate this shaded region here, okay, about the line y equals -1, which is, let's just say, is here. And same game, I'm going to draw a rectangle, and we're going to use the, again, disc washer method, all right? Now, we still need the outer radius and we need the inner radius. So let's take care of the outer radius first. The outer radius, to find it, I'm going to go from the top function here. I'm going to look at the distance from the top function all the way to the x-axis first. And that is going to be cosine of x. And then the distance from the x-axis to the line y equals -1 is 1. And so the outer radius is cosine x plus 1. Now, let's do the inner radius. So if I look at the distance from the bottom function here to the x-axis, that's sine of x. And then the distance from sine of x to the line y equal -1 is 1. And so the inner radius will be sine of x plus 1. So I'm thinking about these in terms of distances. And now I'm ready for my setup. So the volume is pi times the integral from 0 up to pi over 4 of. Now, let's remind ourselves, the outer radius is cosine of x plus 1. So I'm going to take cosine of x plus 1 and square it. I'm going to go minus sine of x plus 1 squared. And then I'm integrating with respect to x. So this is pi times the integral from 0 to pi over 4 of. And I get cosine squared x plus 2 cosine x plus 1, right? Minus sine squared x plus 2 sine of x plus 1 dx. Now, notice how these 1's can disappear here. 1 minus 1 is 0. And so this is pi times the integral from 0 to pi over 4 of. So I'm going to get cosine squared x minus sine squared x plus 2 cosine x minus 2 sine of x dx. Well, cosine squared x minus sine squared x is equal to cosine of 2x. So I get pi times the integral from 0 to pi over 4 of, I get cosine of 2x plus 2 cosine x minus 2 sine of x dx. And now I'm ready to integrate. So this is pi times the quantity, okay? We get 1/2 sine of 2x, that's the first term, plus 2 sine x plus 2 cosine x, plus 2 sine x plus 2 cosine x. And we're going to evaluate from 0 up to pi over 4. If I plug pi over 4 in for x, remember, sine of pi over 2 is 1. And so we get 1/2 plus 2 times sine of pi over 4 is square root of 2 over 2. And then cosine of pi over 4 is also square root of 2 over 2. So we get 2 times square root of 2 over 2 plus 2 times square root of 2 over 2. Right here. Minus, and then when I replace x with 0, I get cosine of 0 is 1. And so I'm left with 2. All right? And so remember, 1/2 minus 2 is negative 3/2. And so when I simplify this, I get pi times the quantity, 2 square root of 2 minus 3/2. And that's how you do problem number 8. Let's take a look at problem number 9. Suppose y equals secant x, y equals cosine x, and x is between 0 and pi over 3. And we're going to rotate this region about y equals negative 1. So again, we have to draw a picture here. Here's y. Here's x. Let's draw y equals cosine of x first. When x is 0, cosine of 0 is 1. That means you're up here. And then when x is pi over 3, so we'll say we're over here somewhere, cosine of pi over 3 is 1/2. And so that means we're somewhere there. So I'm going to draw something like this. Now, for y equals secant x, when x is 0, secant of 0 is 1. And then, just for the record, secant of pi over 3 is 2, which means, let's just say you're somewhere up here. And we're going to go like this. Okay, so we're capped off at pi over 3. Now, we're rotating this region here about the line y equals negative 1, which is here. All right? So I'm going to draw my typical rectangle again, and we're going to use washers. And just like before, we need to know the outer radius and we need to know the inner radius. Now, it's very, very similar to problem number 8. Now, let's not forget, let me change the graph of y equals secant x to blue. So that's going to be this piece, okay? The outer radius is going to be 1 plus secant x. The inner radius is 1 plus the cosine of x. And we're ready to set this up. The volume is pi times the integral from 0 up to pi over 3 of. I'm going to get 1 plus secant of x raised to the second minus 1 plus cosine of x raised to the second dx. So this is pi times the integral from 0 to pi over 3 of. I get 1 plus 2 secant x plus secant squared x minus, and then I get 1 plus 2 cosine x plus cosine squared x dx. Now, notice how the ones cancel, and what I get from here is pi times the integral from 0 to pi over 3 of. I get 2 secant x plus secant squared x minus 2 cosine x minus cosine squared x dx. Remember, I make a big deal about that power reducing formula. Okay? And so this is pi times the integral from 0 to pi over 3 of. We get 2 secant x plus secant squared x minus 2 cosine x minus 1/2 of 1 plus cosine 2x dx. Okay, we're almost done. So this is pi times 2 natural log of the absolute value of secant x plus tangent x. Okay, so that takes care of this first term. And then the antiderivative of secant squared x is tangent x. So we're going to go plus tangent x. That's the second term. Third term is minus 2 sine x like so. I'm going to go minus 1/2 of. Then I get x plus 1/2 sine 2x. X plus 1/2 sine 2x. And then I'm going to evaluate from 0 up to pi over 3. And we just got to do a little bit at a time, right? So if we were to plug this in to our calculator, I get 2 natural log of. Now, secant of pi over 3 is 2. I claim that tangent of pi over 3 is square root of 3. So I get 2 natural log of 2 plus the square root of 3. And then tangent of pi over 3, once again, is square root of 3. Sine of pi over 3 is square root of 3 over 2. So I get minus 2 times square root of 3 over 2. Minus 1/2 of pi over 3 plus 1/2 sine of 2 pi over 3. Okay? And if I replace x with 0, secant of 0 is 1, tangent of 0 is 0. And so natural log of 1 is 0. tangent of 0 is 0. And then if I'm here, sine of 0 is 0. If I replace x with 0, that goes away. And then this term goes away. So I'm basically subtracting 0 when I plug in the lower limit of 0. And I'm going to take it just a little bit further. So we get pi times 2 natural log of 2 plus the square root of 3 plus the square root of 3 minus the square root of 3. And then I'm going to go minus pi over 6 minus 1/4 of. Now, sine of 2 pi over 3 is square root of 3 over 2. So you guys notice I distribute the negative 1/2 inside. So the square root of 3's cancel, like so. And what I get is pi times 2 natural log of 2 plus the square root of 3 minus pi over 6 minus the square root of 3 over 8. And that'll conclude this video for the Chapter 6 review where we did problems 6, 8, and 9. Thank you.